Okay, let's face our the first big problem that we're gonna take now. Well, let's say that you were in a big winter break, so you're on a sled, and the sled is just looking like this, and there's someone over here, I don't know, like here, and there's someone just like commanding you and telling you, dude, go over there, and this guy has like 5 legs apparently, but yeah, and you're just pulling it, and you're like here, and you're just like having a lot of problem just like pulling it, okay? So you know that here that, well, you have no friction and you're just pulling it somewhere. First thing to do is just like have some nice axes. Okay, so let's start drawing them, and there's gonna be it, and there's gonna be it. Okay, my x-axis and my y-axis. So there it is. First of all, we know that I'm just pulling uh the sled. So this is gonna be over here with a force F and an angle of theta. Okay, I know the values, but I'm just gonna write them for now like this. I know also that I have uh, gravity and the weight that's going down and the normal force that's going up. Okay, why is that? Because it's perpendicular to the surface. Okay, so let's first settle the equations. We had to get the sum of all the forces in x. What do I have in x? Well, I do have this force um, and the cosine of theta because it's the projection on the x-axis, and I have nothing else on the x-axis, but I know this thing is moving because my sled is just like moving all around here. Okay, moving from here to here. So that's in x. What happens in y? So we have to do the sum of all the forces in y. So in y I got the normal force that's positive, I got the force that I'm applying times the sine of theta to get just like the impact that it has on the y-axis, minus the gravity, well, minus the weight, excuse me, and this is going to be equal to 0 because it's not moving on the y-axis. Okay, so we need to find the acceleration of the sled. Well, this is kind of easy because we can get it from the x part. Just let me change of colors, and let's go. So, from there I know that f cosine of theta it's equal to mass times acceleration. We need to know the acceleration, so I need to solve for a, which leaves me with uh, f cosine of theta over the mass. If I substitute the values, I'm gonna get 150 cosine of 25 over 80, and this is gonna be 1.7 meters over second. Okay, and this is part A. So for part B, what I'm asked is like to get the normal force exerted by the surface. So this is going to be very easy too, because I can get it directly from the y part, sorry. So I know that the normal force plus the force sine of theta minus the weight is equal to 0. I just need to solve for normal force. So the normal force is going to be equal to weight minus the force sine of theta. So here I'm going to substitute. That's going to be 80 times 9.81 minus 150 sine of 25, and this is gonna be 721 newtons, and this is gonna be part B.